I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we have a set of points which describe sinusoidal function. We'll see how do we write the equation of the sinusoidal function from the given data. You can always pause the video, answer the question, and then look into my suggestions. Well, we'll have two examples in this particular case. Here is the second example, right? So these are the two examples which we are going to work with, okay? So that is the second example. Perfect. So let's take up the sine wave, which is shown here with theta values given as minus 90 degrees, minus 45, 0, 45, and 90, with the corresponding y values as 1, 3, 1, minus 3, 1. We are looking for a sine wave model for the given data. So let us see how do we do it. Well, let me sketch this sine wave first, which sine wave normally is kind of like this, right? Sine wave is like this. And we are given some points. Let's look into what are we given. So as you can see, it starts with minus 90 degrees and 1. So that is what it is. And it goes to a maximum value at minus 45, and the value is 3, correct? And then again comes back to the average value at 0 and 1, and then goes to the minimum for 45 degrees minus 1 and gets back at 90 degrees 1. Makes sense, right? So in this particular case, what do you see? Well, the axis definitely is 1, right? So we know that in the formula which we use y equals to a sine k d theta minus d plus c, we can say that the a value, amplitude, is how far away is it from the axis, right? So 3 minus 1, right? 3 minus 1 gives us a value of 2. Now, k is actually equal to the period. It's related with period. So for a sine wave, the period is 360 degrees. So it is 360 degrees divided by the period. Now period is time taken for one wave. Since it goes from minus 90 to 90, so the value of p is equal to 180 degrees, correct? So I'll write 180 degrees for k and then find for p and then find the value of k, which comes to 2. Now, the sine wave starts from the axis at minus 90. It means it moves 90 units left, and therefore the value of d is equal to minus 90. Since the axis is at 1, the value of c is equal to 1. And so I can write down the equation as y equals to the value of a, which is 2, right, sine the value of k, which is also 2 in this case, theta, d is minus 90, so plus 90 degrees, correct? And c is 1, so plus 1. Do you see that? That is how I can write down the equation for the sine wave. Makes sense? Perfect. Now let's take up the next example. And in the next example, we have almost the same data. However, this time you have to write the equation as a cosine wave. You understand? Okay, so let's quickly sketch the diagram, which we did kind of last time also. So that is the wave, right, which we have, the axis being at 1, right, and the maximum is at 45. This is the maximum, right? Minus 45, 3, correct? So that becomes the maximum. So the cosine wave actually starts with the maximum, correct? So in this case, you see amplitude remains same, which is from axis to this place, right? This is the amplitude, which is 3 minus 1 equals to 2. The period is also same, one full wave, right? So one full wave is period, which is 90 minus 90 degrees, correct? Which is 180. And that gives you the value of k as 2, right? 360 by 180, correct? So K is also same. However, the phase shift, which is D in this case, is now minus 45 since we have a maximum at minus 45. Is that clear to you, right? And the value of C is clearly 1. And therefore, we can write down this equation as y equals to A is 2, right? Cos of K is also 2, right? Theta minus 45 will make it 45 plus, correct? And C, it has moved up by 1 unit. Does it make sense? So for the same wave, you can also write both sine or cosine waves, right? That is how we could do it. So this is a good explanation. Let's take up the next example where we have a wave which you need to write as a cosine function, correct? Now, as you can see, the minimum value is minus 5, maximum is 3. So let's identify. This is your minimum value, right? And that is your maximum value, correct? This is axis, correct? So what is the period? Well, so period is P, which is equal to 390 minus 30, right? 390 minus 30, which is 360, correct? So that gives you the K value also as 1 this case. 360 divided by 360 is 1. Now, axis and the phase shift, right? So axis C is equal to minus 1, right? And the phase shift D is where we get the maximum value or the minimum value, right? So the maximum value is 210. So for cosine, D will be 210 degrees to the right. So I think that helps to write down the complete equation, which should be y equals to the value of A. Well, A I didn't find here. A is the value between the difference between the maximum and the axis, right? So it is 3 minus of minus 1, which is equal to 4, right? So we have 4 as value of A, cos of the value of K is 1, and so we can write theta minus D. D is 210, it starts with maximum at 210 degrees, right? Plus C, which is minus 1. So that is how you can actually get the equation from the given data. So I hope that helps, right? So with that, we come to an end of this particular video where we have understood how from the data we can write sine or cosine wave functions. These are called sinusoidal waves, right? In case you want to learn from me, you can always send an email on the address given. Thanks for your time and all the best.